to the course on noise control in mechanical systems with myself, Professor Sneha Singh from IIT Roorkee, and in today's lecture we will begin our discussion on active noise control. So, this is the brief outline. We will introduce active noise control, which is one of the major strategies in noise control. So, we know that in noise control we have an active noise control. These are the broad categorizations of path based noise control, and then we have passive noise control. Both of them are like path modification based noise control methods. Okay. So, we will see what is active noise control, what are the basic systems, components and working principle of an ANC system, and what are the types of ANC system. Okay. So, let us see active noise control, a slight introduction was given in some of the previous lectures. What is it? It is, we will call it as ANC in the acronym of that. So, this is a technology where you try to reduce or cancel any unwanted sound by creating a secondary sound. So, if the sound is there, we create another sound which is antiphase to the target sound, and it works on the principle of destructive interference. So, what happens, suppose you have got this sound that is present in a space, and then this is your primary source which is creating the noise. Then what you do is you have a secondary source somewhere in that space. It could be a speaker or something like that, some kind of secondary source. And then the secondary source is such that it should always create the sound level which is in antiphase. So, 180 degree phase shift, exactly same waveform, 180 degree phase shift with this. So, what happens, the two waves will destructively interfere, causing a flat signal. This should be the end result. So, that is how it works. So, you have the noise source, you have an anti-noise source. So, usually this secondary source is also called as the anti-noise source, because it is generating a signal which is antiphase to the already present noise signal, which is called as the anti-noise signal. So, these are some of the terminologies used in active noise control. So, you generate the anti-noise, the two are out of phase with each other, so that when they sort of combine, there is a destructive interference, and the pressures, they cancel each other. So, ideally if everything was okay, they should just cancel perfectly, there should be perfect cancellation or perfect destructive interference, and the sound level should dim down and become 0. But because in the real world you have so many kind of inherent random errors and variables. So, not always you get, in fact in most of the cases you do not get perfect cancellation. So, there is some small level, there may be an imperfect cancellation, but either way, because it is antiphase, so either way the noise level reduces significantly. That is what happens. So, this is like how a basic ANC system would look like, because the secondary source or the anti-noise source has to at every point in time generate an anti-noise or a signal which is antiphase with the original sound signal. So, that means that there should be some mechanism through which the secondary source should know what sound signal to generate. Okay. So, the secondary source should know that this is the current sound present in the environment, and I have to create a signal which is antiphase with it. So, there should be some mechanism to measure the sound signal and give this feedback to the secondary source, which is the anti-noise source. So, that is what we have, what is happening. Whatever noise source is there which is emitting the sound signals, the mechanism to measure it should be a microphone. So, some microphone is present, usually closer to the sound source, it measures. So, whatever is your space of interest, let us say this is our space of interest, as in the space where which we want to cancel. Okay. And in the previous lectures you saw that ANC is very space dependent. So, it does not mean that if I have an ANC system it is going to cancel the noise throughout in a larger area, but it is very spatial and localized. So, whatever is that location of interest, you have a microphone and you measure that due to the noise source, what is the sound level in your region of interest. Okay. So, it measures the sound level in the region of interest, it gives it through some controller mechanism which drives the anti-noise source. So, based on whatever signal it is measuring, it will have some controller and actuator mechanism that will drive the anti-noise source, and the anti-noise source would simply be whatever is the measured signal, do a minus sign, convert it into an anti-phase signal and keep generating the anti-noise. So, the sound source, if it starts to vary from this to let us say this or like this, whatever, then the microphone will keep measuring, doing this controlling mechanism, and then this will also change its response based on whatever is the measurement. So, suppose in the second scenario the signal was something like this, lower frequency, higher amplitude. In some third case you had some random signal like this, something like that. So, based on whatever data has been measured, the anti-noise signal would be created which is anti-phase to it. So, this will create something like this, if this is the sound wave that is coming up, it should be anti-phase of this, like this, I think so, let us see, yeah, something like this. In the same way for this one it would be some anti-phase signal, again inverted in the other way. I will create a simple signal just for simplicity for my own sake and make the point clear. Something, I am just creating some patterns so that I make my point clear. So, again based on this, whatever is the measured signal, the controller will drive the secondary source so that it creates something anti-phase to the measured signal. So, now in this case what it will create is some sound source which is anti-phase to the measured. So, it would be something like this. Like this. So, whenever these two add up in the first case, so whenever these two add up, they have a net zero effect. In the same way, whenever these two add up, they have a net zero. So, always it is a destructive interference. So, this is how the basic ANC system is. You have a noise source, you have some microphone in your space of interest, you have a controller plus actuator mechanism to drive the secondary source, which then dynamically based on the measured signal creates an anti-noise. This shows a typical ANC setup within an automotive car. Usually in the automotive cars these days in the advanced, because you have so much of vehicle electronics embedded in an automotive environment, with that you can connect your ANC system very well, because there are already a lot of electrical and electronic components. So, this integration of ANC system becomes very kind of seamless within an automotive environment. This shows one such example where you have got a speaker at the front. So, your passengers sitting in these seats are of interest. You want to cancel the noise near the ear of these passengers. Okay. So, whatever are the noise sources, let us say the engine and this part is creating a lot of noise. Okay. So, you can have some mechanism. So, and this is your space of interest. Okay. Your space of interest is you are not bothered about what is the noise here or here. So, you are not bothered about where the source is and what kind of noise it is creating. You are bothered about what is the noise level at the space of interest, which is what is the noise level where the listener, your target listener is residing. So, you keep your microphone where you would like to cancel. So, you would like to cancel the noise where the passengers are sitting, and hence you have an array of microphones closer to the passenger's location, and they are measuring the sound signal, and then it is passing on. So, this reference signal is then passing on to the adaptive controller. The controller or some kind of mechanism is there which is going to give this, that okay, this is the measured sound signal. So, you should from these speakers generate the kind of anti-noise signals, and in the same way. So, this will help the back passengers, and the same controller can then react, can also be connected to a speaker systems on the front. So, in the car you already have these speakers in the front and the back. So, sort of embedding an ANC system becomes very seamless. You have the microphones near the passenger, you measure the sound levels, you have some controller mechanism that then finally drives and gives the signals to the already installed speaker systems of the vehicles, then they create these anti-noise signals which automatically cancel out and dim down the noise near the passengers. Okay. This also shows that these sometimes you have the speaker systems directly installed at the seats very closer to the the passengers. So, what are the major components in ANC system? You obviously have the various kind of microphones to measure what is the sound level, because that would become your input for the generating the anti-noise. So, in the microphones you can have two types of microphones, external microphone and internal microphone in an ANC system. The external microphone is positioned on the outside of the ANC system and it picks up what is the ambient noise just before it reaches the listener. Okay? And the internal microphone is located very close to the listener's ear. Sometimes it is inside the listener's ear. In the case of that, suppose the listener is wearing a headphone. You have various kind of ANC headphones. Okay? You will see in the market you have various ANC headphones that are available. So, here the microphones or whatever is located next to the ear in the earphones and all and headphones, that becomes your internal microphone, which is located just at the listener's ear. So, this is it helps in adjusting the noise cancellation for a better accuracy. So, what happens here is that, let us say from one microphone, this is your listener's ear and this is your secondary microphone. Okay. So, this is your external, this is your internal. So, here the two microphones work together. So, mostly you can also do the same thing with a single microphone, but for better accuracy and for better real time adjustment, you use these external and internal microphones. So, external microphones, they measure the signal just before entering. So, what happens that they measure that, okay, this is the sound signal which is about to reach the speaker, okay, whatever is the sound signal, it is just about to reach the speaker, they would measure it, they would send it to the controller mechanism, okay, and then the controller will immediately create an anti-noise and send it to the listener's ear, so that the listener, the noise gets dimmed down. But in the pathway from here, because the measurement took place here, so from here to here the noise can have slight changes. So, you may not achieve perfect cancellation just based on what you measured over here. So, you have an additional microphone just at the ear. So, when the cancelled noise comes in, this additional microphone records what is the cancelled noise at the ear. If it is 0 dB or perfect cancellation, nothing happens. But if it is not 0 dB, because whatever was measured before the ear, there could be some transformations from the external to the ear, and perfect cancellation may not always be achieved. So, the internal one then measures whether perfect cancellation has been achieved at the ear or not. So, perfect cancellation, then nothing is done. If it is imperfect, there is still a noise level remaining, it will pass it as an error signal to the controller mechanism, which will tell you that some kind of adjustment needs to be done to the anti-noise so that a perfect cancellation is achieved. Okay. And you have obviously for all these processing and to create the various kind of signals, you have a typical DS, the digital signal processing, which detects the signals from the microphones and generates the anti-noise signals. So, it detects both the reference signal from the first microphone, the error signal from the second microphone, and based on this it creates an anti-noise signal which is based on the feedback from both these microphones and so on. Then you have a speaker which will create. So, the signal, what the output signal that is passed, which is an anti-noise, is then passed on to the speakers which then create the anti-noise signal to cancel out the unwanted noise. You obviously, for all these systems to work, whether it is microphone, your digital signal processors, your speakers and all these they are all these systems which work through electrical power and lot of circuits are there. So, you need some form of power supply, be it a battery or an external AC power source, but you need some kind of power supply. Okay. So, I have already explained this mechanism, some external noise is there before reaching the listener ear. So, you need the external microphone that as soon as the noise begins, the listener hears a cancelled noise. So, before reaching itself, you measure or capture the noise, and that is sent as a reference signal to the DSP, which creates an anti-noise based on whatever signal was measured by the external microphone, and then this anti-noise signal is passed on to the speakers and the actuator mechanism, which then emit this anti-noise which reaches the listener's ear. But whatever noise is actually reaching the listener ear, you have an additional component called as the internal microphone. It monitors that whether whatever anti-noise was calculated based on these measurements, if there is due to some phenomenon, just the physical nature of this space itself, there could be some diffractions, something which we might not have accounted for, due to which there is not perfect cancellation. So, it measures whether a perfect cancellation is achieved at the ear or not. If it is not achieved, then it passes an error signal and feedback to this. Okay. So, basically it is passing this feedback again back to the DSP based on whether perfect cancellation is achieved or not, and then this DSP would readjust its anti-noise signal in the real time to get a perfect cancellation. Okay. So, all of this I have explained what is the process like and how the two microphones work in sync to reach perfect cancellation. So, whenever we have a varying environment also because of these two microphones that are working in sync, whatever is the anti-noise, it can adjust dynamically in time based on whatever is the error signal being passed from the internal microphone. Now, there are various types of ANC systems. In fact, if you go into the literature of ANC, you would have countless various kinds of ANC system, but we will just sort of decompose it down to three basic mechanisms which we will briefly see in this course. And based on what kind of application and what kind of environment your ANC is applied, you can take and pick one of these types of ANC system. So, it is the feed forward, feedback and the hybrid ANC. Let us see the feed forward ANC. Now, I will discuss all of this in context. Let us discuss them in context of an ANC headphone. Okay. So, you have an active noise cancellation headphone, which is quite common now these days in the commercial markets. You have these headphones which are cancelling the machinery noise or whatever is, because you use the headphone for listening to music etc., and any other machinery noise, construction noise etc., you would like to cancel it out. So, you can use these ANC headphones. So, let us study these three systems in context of this. So, the very first one is the feed forward. So, what happens here? Okay, active noise cancellation comes from an externally facing microphone. So, here what you have is, I told you about an external microphone and an internal microphone. So, here you only have this feed forward mic or the external microphone. So, this is the microphone which is facing the ambient environment around the listener. It is not located exactly in the ear, inside the ear. Okay. So, this is just before the sound is about to reach the listener. So, before that it is present. So, that measures what is the sound which is approaching the listener. So, it measures the sound approaching the listener, and based on that it creates an anti-noise signal which then plays through the speaker into the listener's ear. Okay. So, whether a perfect cancellation has been achieved or not, you never know, because there is nothing like an error signal. Okay. It just measures what is the sound approaching. Based on that, it creates an anti-noise which goes into the listener's ear, and then this sound which approaches, hopefully it has cancelled it. Perfect or imperfect, we do not know. Okay. So, what are the advantages and disadvantages? So, this feed forward ANC system is good at cancelling various high frequency noises and less effective with unpredictable or rapidly changing noises. Suppose it is a rapidly changing noise. So, suppose especially for example, in a location where the noise is varying, having a lot of spatial variations. So, let us say the noise which was approaching here, due to some diffractions that are happening in the environment itself, here due to some diffraction it might have changed. Okay. What is achieved here, it might have changed. So, in that case your perfect cancellation will not be achieved. So, in these unpredictable environments it might not work. The second type of ANC system is where you have only the internal microphone or the feedback mic. Okay. So, what happens, active noise cancellation happens with this internally facing microphone. So, what happens is the noise approaches and sort of reaches the listener, and the microphone just next to the ear detects it and then it drives the DSP mechanism to create the anti-noise. And due to this, what happens is that in the feed forward, suppose it is a very dynamic environment with lot of structural elements and lot of unpredictability in the sound wave variation, perfect cancellation may not always be achieved, because you never know that the sound that was measured at time t equals to 0, and then it reaches the listener's ear at t equals to whatever, let us say t time. So, whether that is same and whether the reference signal, whatever anti-noise signal is there, is able to cancel it perfectly. You never know what happens in the ear, because you have no microphone there in the feed forward, but in the feedback you have the microphone right at the listener's ear, and it measures what is the noise actually present in the listener's ear, and based on that it sort of creates the feedback mechanism and it drives the speaker to create an anti-noise. Now, if you see here, the noise has reached over here, okay, and then what has happened? Then based on that some reference signal is generated to sort of create an anti-noise signal. What if by the time this noise has reached here and the next set of wave fronts are something different, right? So, you measure this reference signal, you send up this, and a new signal is created anti-noise to it, but by that time it is created and reproduced, a different form of signal has reached the ear. So, which means that here there is always a lag. You first measure, create the signal and generate the sound. So, there is always a time lag. So, if you do not have steady environment, then in that case this lag is quite visible. Similarly, if you have high frequency sounds, which means rapidly fluctuating sounds with respect to time, again this lag from the measurement of the signal at the ear to the generation and the creation of the anti-noise, this lag becomes very evident at higher frequencies, and hence this delay in the response is there, especially at the high frequencies. But suppose you have a low frequency noise which is very steady, so especially when you have a low frequency and very steady noise, then this system will correct the errors and give you more perfect cancellation compared to the feed forward system. Then we have the hybrid system. So, when I discussed about the working of the ANC system, I had mentioned both the internal and the external microphone. That is the mechanism used in the hybrid ANC system. You have both feed forward mic or the external mic and the feedback mic or the internal mic, okay, same things, okay. And this is the headphone. So, it measures the noise just before reaching the ear. So, what is the ambient noise around the ear? Then the refresh signal is created, and by the time that noise reaches the ear, cancellation happens. But there is also additional mic present at the ear to see whether the perfect cancellation has happened or not. If it has not, it carries the error signal and adjusts the anti-noise signal dynamically by giving this feedback back to the NC system, okay. So, whatever is there and some kind of error signal and adjustment happens to the already created anti-noise signal. So, in the dynamically changing environment, and these environments they can quickly adapt and change the anti-noise signal. So, the advantages are that now they can work both for the low, because they are combining both these features, So, both low frequency, high frequency, so much broader spectrum of noise cancellation is achieved, and they are better, more adaptable to dynamic and varying fluctuating noises, dynamic environments and fluctuating noises, but they are more complex and costly, and because they need multiple microphones, so more costly and more advanced processing, that is obviously the disadvantage, but they have a more better adaptability and better results in almost all the frequency ranges. So, with this I would like to close the lecture on ANC. Thank you.